Hey everyone, welcome to How to Configure OpenRoaming on the Cisco Catalyst 9800. My name is Justin Liu, a technical marketing engineer here in Cisco's Enterprise Network Wireless BU. Today, we're going to go over what OpenRoaming is and how it works, then we'll go over how to enable this on your Catalyst 9800 access network. Before we get started, please ensure that you have already added the DNA Spaces connector and 9800 WLC to your DNA Spaces account, and ensure you have at least the DNA Spaces C license in order to enable OpenRoaming. If you have not, please watch the DNA Spaces 101 Episode 2 video where we'll cover how to do this. You can find this video in the description below. So why do we need OpenRoaming? Well, there's been a push from device vendors for randomized and changing MAC addresses or RCM when joining a wireless network to prevent user tracking when using MAC address. The end devices will generate a new MAC address whenever they join a new SSID, and some devices will even generate a new MAC address when joining the same SSID. So the issue lies in how can network operators balance the privacy goals of the user with their own network operation goals. With RCM, this will impact network operations like the captive portal, proximity reporting, and analytics data and applications. Due to the MAC address changing, returning visitors to the network will be reported as a new device, so this will cause them to be redirected to the captive portal many times. Also, this will have an adverse effect on the proximity reporting, as the devices identified by MAC will also be listed multiple times, and this will also affect guest metrics such as dwell time and visitor count. To help solve this, OpenRoaming provides a way to generate a device ID to identify devices while also giving users a way to prevent their real identities from being shared with the wireless network provider. Also, OpenRoaming will provide seamless and secure guest onboarding experiences because traditionally, guest wireless networks have been open networks that sometimes first show the user a captive portal where they will have to enter in their information before they can access the network. On open networks, your data is not secure, and unless you use something like a VPN, you're always at risk. And while using the captive portal, these are often cumbersome and sometimes do not trigger, causing the users to be caught in limbo where they're connected to the Wi-Fi network, but they actually cannot access anything. With OpenRoaming, the user devices will use an OpenRoaming profile installed on their device to automatically join an 802.1x secured wireless network, providing users a secure connection while bypassing the need for a captive portal. So now that we know some of the reasons why we have OpenRoaming, let's see how it works. OpenRoaming is a consortium of identity and access providers to enable seamless roaming and onboarding for user devices. Access providers are the wireless networks that you would connect to, like those at hospitals, retail locations, and hotels, while identity providers authenticate the device to ensure that they are valid users who can access the network. OpenRoaming is under the WBA and provides the access providers with the ability to reach all the identity providers, and all the identity providers a way to reach all the access providers. And how is this done? This is done through abstraction. So let's think of a credit card. Everyone uses a credit card because every store takes it, and every store takes it because everyone carries a credit card. With the credit card, the stores do not need to have a relationship with every bank, they only need to create an abstraction, the credit card. The banks join a credit card, and the stores use that credit card, allowing any store to connect to any bank. This is exactly what OpenRoaming is. It allows any identity provider to be used by any access provider. So now, let's see a typical OpenRoaming journey to see how this works. So first, the access network and identity provider, or IDP, will need to onboard to the OpenRoaming Federation. During onboarding, the access provider and IDP receive certificates from ecosystem brokers like Cisco. These prove their identity and verify the assets they own, like the access network or a set of identities. This allows for the access network and IDP to authenticate each other when they communicate. Next, the IDP configures DNS so it can be discovered in the Identity Federation. The access network then configures its wireless network to use 802.1x authentication and to leverage Hotspot 2.0 and 802.11u protocols to advertise to end devices that it supports OpenRoaming and to let devices know which identities it accepts. Now, when a user roams into range of the access network, if the device has an identity that is accepted by the network, it will then use that to join the SSID. EAP is used to secure the credentials sent from the client to the access network, and this is typically EAP TLS, TTLS, or AKA, and the identity will be decorated with a realm, such as Cisco.com. The access network will then use the realm and DNS to dynamically discover the IDP. It will then create a TLS tunnel to the IDP with the certificates downloaded from the ecosystem broker, and the access request will be sent via RADSEC to the IDP. If the user is valid, the IDP will return the access accept to the access network, as well as the identity of the user if the user had chosen this. Now, the device will be able to access the network. Today, we'll be focusing on the access network, and this is made up of three components: the 9800 controller, the access points, which can be the Catalyst 9100 series APs, as well as our Wave 1 and Wave 2 APs, and finally, the DNA Spaces connector. The controller and APs define the Hotspot 2.0 and OpenRoaming compatible 802.1x networks, as well as receiving the client join requests and then forwarding these requests to the DNA Spaces connector. The connector serves as a radius proxy for the network. It will dynamically discover the IDP and forwards all the radius requests to the IDP over RADSec. So now, let's go configure OpenRoaming on our Catalyst 9800 network. So there'll be 5 main steps to configure OpenRoaming. First, you'll have to add the DNA Spaces connector as a AAA target on the Catalyst 9800. Next, we'll have to configure the OpenRoaming WLAN. And then we'll enable the OpenRoaming hotspot connector on the DNA Spaces connector. Then we'll configure the OpenRoaming hotspot ANQP server. And finally, we'll enable OpenRoaming for the WLAN. Once that's done, we'll verify the connectivity of our newly created OpenRoaming network. So now that we're in the web UI of the 9800, let's go configure the DNA Spaces connector as a AAA target for our network. To do this, we'll go to Configuration, Security, AAA. So now under the Server/Groups tab, under Radius Servers, I'm going to click Add. And then for the name, I'm just going to say OpenRoaming Connector. And then for the server address, we'll put the IP address or hostname of the DNA Spaces connector. Next, for the key, this will be RADSEC as shown on the screen, RADSEC, all lowercase. And then we'll click Apply to Device. Now we'll apply this radius server to a server group, so we'll click Server Groups, and then click Add. I'm going to name this OpenRoaming Group. And then for MAC delimiter, we're going to set this to hyphen. And then for the source interface VLAN, if you have a specific VLAN that has connectivity to your DNA Spaces connector, choose that. I'm going to choose VLAN ID 12. And then select the OpenRoaming radius server and then apply that to the assigned servers and click Apply to Device. Now we'll apply this radius server group to a AAA method lists. First, for under authentication, we'll click Add. And here, name this whatever you need to name this. I'm going to name this OpenRoaming Authentication. And then for type, I'm going to choose .1x and leave group type as group. Now I'll select the OpenRoaming server group and apply that to the assigned server group and click Apply to Device. Now we'll go to Authorization and click Add. I'm going to name this OpenRoaming Authorization. And then for type, I'm going to choose exec and leave group type as group. Next, I'm going to select the OpenRoaming server group and apply that to the assigned server group and click Apply to Device. Lastly, we'll go to Accounting and click Add. I'm going to name this OpenRoaming Accounting. And then for type, I'm going to choose Identity. And then choose the OpenRoaming server group, apply it to assigned server groups, and click Apply to Device. Now we'll go to AAA Advanced tab, and under Global Config, Show Advanced Settings, ensure that the called station ID for both accounting and authentication is AP MAC address SSID. And then click Apply to Device. So now that it's saved, let's go configure our OpenRoaming WLAN. To do this, we'll go to Configuration, Tags and Profiles, WLANs. Next, we'll click Add. Here, name the WLAN whatever you need to name it. And then the SSID will also auto-populate, so you can change that as well. Next, set the status to enabled. Also, ensure that broadcast SSID is enabled or devices will not join the OpenRoaming network. Next, we'll go to the Security tab, and under Layer 2, choose your preferred Layer 2 security mode. I'm going to leave it as WPA plus WPA2. Then we'll scroll down to the Auth Key Management and ensure that 802.1x is enabled. Next, we'll scroll up and go to the AAA subtab. And here for the authorization list, select the OpenRoaming authentication list that we had created earlier and click Apply to Device. So now that we've created the OpenRoaming WLAN, we'll go to the DNA Spaces dashboard to configure the OpenRoaming hotspot connector for our DNA Spaces connector. So now that we're in the DNA Spaces dashboard, let's go open the OpenRoaming app. To do this, you can either click on the OpenRoaming tile under See Apps, or if you go to the top right and go to the app selector, you can also choose OpenRoaming. Here, I've already configured OpenRoaming previously, so I'm redirected to an OpenRoaming statistics page. However, if this is your first time, you'll be redirected to an OpenRoaming Getting Started page. To access this, you can actually click the hamburger menu and click Get Started. So regardless of where we were redirected, let's go access the setup page. To do this, we'll go back to the hamburger menu and click Setup. On the setup page, there are 3 main steps. We have to first create an OpenRoaming profile, and then set up a hotspot enabled connector, and then finally we'll do the network configuration. So let's go create our OpenRoaming profile. This will define the types of identities which are accepted by our access network, as well as defining any service provider offload settings for the network. So to do this, let's first click Create OpenRoaming Profile. Now in the window, let's click Proceed. And here is the access policies, so this will be the types of users that can access the OpenRoaming network. The identities are all authenticated users, which is default, except only users that provide a real identity to the access network by sharing their email, except users with specified identity types, as well as accept only your users, but you'll be needed to add as an identity provider. For the specified user types, you can choose whether or not you want like device manufacturer ID or cloud social ID, as well as toggling whether or not you want them to provide a real identity. So for example, I can select all identity types and then toggle I want to require real identities. In my case, I'm going to leave this as default, accept all authenticated users. Next, you can set preferred credentials. So if you prefer credentials from your domain, you can set that here. So all you have to do is check I have preferred credentials. And then in the drop-down domain, go select the available domains here. And if you do not see yours, you can click Add Custom Domain, enter the domain, click Save and Add, and then click Add to save the domain. But I'm going to click I do not have preferred credentials, and then click Next. And here for the SSID details, this will be the SSID name of the WLAN you had configured earlier. So in my case, I'm going to name this OpenRoaming Video. So if we open the advanced options, we can see that there's the default status as well as fast transition. For default status, this can be enable or disable. And fast transition is adaptive, enable, or disable. I'm going to leave this default as a default status enabled and fast transition adaptive. Now we'll click Next. And here is where you'll set settings for carrier offload. So if you want this to be enabled, you'll have to make sure you have the DNA Spaces Extend license at least, and then have an existing relationship with the carrier. So after toggling Allow Carrier Offload, scroll down in the list to find the carrier that you want to have. And once you find it, you can check the box next to it to enable that. And if you want to enable static routing, you can also check the box for enable. I'm not going to configure carrier offload, so I'm going to disable it now, and then click Next. And here in the summary page, it'll give you an overview of what you have configured. So in my case, I have access policy as allowed users are accept all authenticated users. Preferred credential is no preferred credentials. The SSID is OpenRoaming Video with default status of enabled, and fast transition adaptive with no carrier offload. And then for the profile name, this will be auto-populated by the SSID name, and you'll refer to this when you save it, so we'll click Done, and then click Continue OpenRoaming Setup. So now let's enable the hotspot connector on the DNA Spaces connector. So to do this, you'll have to make sure that your DNA Spaces account is linked to your DNA Spaces connector. So if you haven't done that, please do that now. So now let's go enable the hotspot connector. So we'll click Enable Hotspot for Connectors, and then choose the required connector. The list here will be populated by the Spaces connectors that are linked to your account. So I'm going to select Just Lu DNS connector and click Continue. And here we'll have a token generated, and you'll copy this token to the DNA Spaces connector, and this will be used to download the necessary certificates for OpenRoaming. So for security purposes, this is a one-time use token. So please do not use this token to deploy the hotspot connector on any other DNA Spaces connectors. So now click copy and we'll go over to the DNA Spaces connector UI to paste the token. Now that we're in the Cisco DNA Spaces connector UI, we'll go apply the token. To do this, we'll go click the settings icon in the right corner and click configure token. Here, paste the token that we had copied over and click save. So now the Spaces connector will download the necessary hotspot connector Docker images and deploy it onto the DNA Spaces connector. This may take a few minutes, so we'll come back once this is done. So now we're back, and to ensure that the hotspot connector has been successfully installed, there is now a hotspot tab here in the UI. So if we click on that, we can check the top right corner and see that it is set to running. So now we'll go back to the OpenRoaming setup to enable the hotspot ANQP server on our 9800. So now that we're back in the OpenRoaming setup page, let's go generate the configurations for our controller to generate the hotspot ANQP server. To do this, we'll scroll down to the network configuration section and search for the necessary Catalyst controller. The controller list is populated by adding the controller to DNA Spaces. So once you've found the necessary 9800 controller, you'll hover over it and on the right side, and then we'll click on the gear icon. And in the configure controller window, we'll select the OpenRoaming profile we had configured. So in this case, we'll select OpenRoaming video. And here it'll give you a summary view again of what you had configured just in case you had forgotten. So in this case, access policy is accept all authenticated users with no preferred credentials, an SSID of OpenRoaming video with default status enable and fast transition adaptive, and carrier offload disabled. Now we'll click continue. And here you'll choose Catalyst 9800 as the controller type. And next for the WLAN name, we'll enter again the WLAN we created, so OpenRoaming video. And then we'll click show configuration. And here for the type, if you have 17.2.1 running or higher, choose Catalyst 17.1/17.3.1. And if you're running anything earlier, you'll choose Catalyst 16.12.1/17.1.1. The generated configurations will be used to create the hotspot ANQP server for OpenRoaming, and the settings here are created based off the settings defined in the OpenRoaming profile. Also, the configurations include applying the hotspot ANQP server to the default wireless policy profile, and then mapping the default wireless policy profile to the WLAN that you created. If you are not using the default policy profile and policy tag, you can just copy the settings for the hotspot ANQP server. I'm not going to be using the default wireless policy profile nor the policy tag, so I'm just going to copy the settings for the hotspot ANQP server. So starting from the OpenRoaming OI line, we'll select that and go all the way up to the wireless hotspot ANQP line. And then we'll copy that, and now we'll apply this to the CLI of our 9800. So I'm going to be using the command line interface tool in the web UI of the 9800 to apply the configurations. So to do this, we'll go click Administration and then go to Command Line Interface. Here we'll select the Configure option, and then we'll copy and paste over the configuration from DNA Spaces. And then we'll click Run Command. And here, double check that all the commands have command executed successfully for all of them. Next, we'll apply the hotspot ANQP server to our wireless policy profile. I've already created a wireless policy profile, so we'll be just going over how to apply this to it. So we'll go to Configuration, Tags and Profiles, Policy. And here I'm going to select my OpenRoaming video wireless policy profile. And this is just a standard central switching, central authentication, and central DHCP enabled. So now I'm going to go to the Advanced tab. And here on the hotspot server, we'll go select the OpenRoaming server that was created. And then under AAA policy, we'll go apply the accounting method list we had created for OpenRoaming. And this will report the statistics back to DNA Spaces. So now we'll click Update and Apply to Device. Now that it's done, we'll go to Configuration, Tags and Profiles, Tags. And here we'll create an OpenRoaming policy tag. So we'll click Add and name this OpenRoaming. Then we'll click the Add button under WLAN Policy Map, and then choose the WLAN profile for OpenRoaming, as well as the wireless policy profile. Then we'll click the checkbox to save the mapping, and click Apply to Device. Next, we'll apply this to our APs. So we'll go Configuration, Wireless, Access Points. I'm going to select my AP and choose the OpenRoaming policy tag, and then click Update and Apply to Device. So now the AP will have to disjoin and rejoin the controller, so we'll come back once it has rejoined. So now that the AP has rejoined, we can verify that it has indeed have the OpenRoaming policy tag. So now let's go verify the connectivity of our OpenRoaming network. And to verify the connectivity, you can use either an Apple or Android device running the OpenRoaming mobile app. The Apple devices need to have iOS 13.3 or higher, and the Android devices need at least Android 9 or higher. The OpenRoaming mobile app will be used to download and install the OpenRoaming profile onto the device. You can also use some devices which do not require the app to download the OpenRoaming profile, and these are the Samsung devices which run Android 10 or higher, as well as Google Pixel running Android 11 or higher. I will be using my iPhone running iOS 14 to verify my OpenRoaming network. So now that I'm in my iPhone, let's go connect to the OpenRoaming network. First, we'll open the OpenRoaming mobile app and sign in with either Apple or Google. I chose Apple, and click Continue. Next, this will take you to a Terms and Conditions page, so you'll have to accept the terms and conditions and then click Continue. And here you can choose whether or not you want to share your email with the OpenRoaming providers. I'm going to choose to share it and then click I understand. And here it'll ask if you want to install the Wi-Fi hotspot network. Click Allow. So now the OpenRoaming profile has been downloaded and installed onto your phone. In the usage page, you'll see the different OpenRoaming networks that you connected to previously. And then if you go to the account page, you'll see the account that you had signed into, as well as if you want to log out, delete the account, or if you want to toggle whether or not you want to share your email ID. If you choose to not share it anymore, you'll just have to untoggle that. Next, you'll get a warning saying you may not connect to some access networks, but if that's okay, click Proceed. Then you'll also get another pop-up asking you to reinstall the OpenRoaming profile, so click Allow. Additionally, you can check the different devices you had logged into in the Device tab. So in my case, I've logged onto 2 different iPhones. So now let's go to the Settings app to check whether or not we can connect to the OpenRoaming network. So now I'm just going to re-enable the Wi-Fi. I had disabled it just so that the network wouldn't automatically connect to my phone. So now if you notice, the OpenRoaming video SSID is not in my known networks. So if we wait a few seconds, it'll then automatically be selected without any action from me, and I'll be connected. So now I'm going to turn off the Wi-Fi in order to simulate going in and out of range of the OpenRoaming network. So once I enable it, again, you'll see that it's not in my known networks, but it'll automatically be selected and connecting to the OpenRoaming video SSID, showing a simple and secure onboarding experience. And with that, we've reached the end of this video. In summary, we learned exactly why we need OpenRoaming, how OpenRoaming works, and then how to configure it on our 9800 controller. If you enjoyed this video, please give it a like and subscribe to our YouTube channel. Thank you for watching.